All right, so get this. What if AI could actually do science?
Like, actually do it.
Not just, like assist researchers, but like come up with the ideas themselves, design experiments, and maybe even write the papers.
Yeah, like full-on scientist AI.
That's what we're going to peek into today.
It's a wild world, and it's getting wilder by the day.
We're talking large language models.
Those AI powerhouses like ChatGPT.
But instead of like writing poems or whatever,
These are trained on scientific data.
yeah, so they can actually understand and contribute to research.
And it's not science fiction anymore.
So how do we even begin to unpack this?
Well, there's a whole field exploding right now.
Yeah.
It's called LLM4SR, which stands for Large Language Models for Scientific Research.
Catchy.
And we've got a great guide for this deep dive, a survey paper from just this month, January 2025.
Oh, wow, so it's cutting edge.
It's called LLM4SR, a survey on large language models for scientific research. A team from the University of Texas at Dallas and Nanyang Technological University put this together.
So we're talking top-notch research here.
Absolutely. This is the forefront of the field.
So back to these AI that can come up with new scientific ideas. I mean, how does that even work?
Right. It's not like they just read every research paper ever published and then spit out something new.
Yeah, that would be kind of like a super-powered plagiarism engine or something.
Huh. Yeah, not quite. It's more nuanced than that. The key idea is that a lot of scientific breakthroughs come from connecting existing knowledge in new ways.
Okay, so like making those unexpected connections.
Exactly. Think of it like those moments where you're working on a problem and suddenly two completely unrelated ideas click together.
Oh, yeah, and you're like, aha.
Exactly. That's the kind of spark these LLMs are trying to recreate, but on a massive scale.
So it's not just memorizing facts, it's about finding those hidden links, those sparks of insight that lead to truly new discoveries.
Right, and to do this, they're drawing on two key research areas: literature-based discovery and inductive reasoning.
You could break those down for me. Literature-based discovery sounds pretty self-explanatory.
Yeah, it's basically what it sounds like. Imagine an AI that can sift through millions of research papers, find those subtle links between seemingly unrelated studies.
And point us towards potential breakthroughs that we humans might have missed.
Exactly, and that's just the beginning.
Yeah.
Then you've got inductive reasoning, which is all about finding general patterns from specific observations.
Okay, like if you see enough apples fall from trees, you figure out that gravity's a thing.
That's the basic idea, but these LLMs are doing it with massive amounts of scientific data. They're finding patterns that could lead to new scientific laws or principles.
That's both fascinating and a little intimidating.
It is a lot to wrap your head around.
But we're talking about AI actually generating hypotheses, right? Like coming up with scientific ideas to test. But how do we know those hypotheses are any good?
That's the million-dollar question, right?
Yeah.
We don't want scientists wasting time chasing down AI-generated rabbit holes.
Exactly. It needs to be quality stuff, not just random ideas.
Right, and that's where the whole main trajectory of these LLM-based discovery methods comes in. It's all about building in checks and balances to make sure the AI is on the right track.
Okay, I'm all ears.
Hmm.
What are these checks and balances?
Well, first, you need the system to find those nuggets of inspiration. Some of them are pretty straightforward, like a system called Simon.
Okay.
It looks for papers that are semantically similar to the research topic at hand.
So kind of like a really advanced search engine for scientific literature.
In a way, but then you've got systems like Moose that use the LLM itself to pick the most promising inspirations.
Oh, hold on. So the AI is deciding what's going to inspire it.
It's like saying, hey, AI, which pieces of information here are most likely to lead to a breakthrough?
So it's curating its own inspiration. That's pretty meta.
It is, and it's surprisingly effective. Researchers testing MooseChem on chemistry papers found that the LLM could actually predict which pieces of information inspired real discoveries.
Wow, so it's like the AI has a sense of what's scientifically important.
It's wild, right? But finding inspiration is just the first step.
What happens next?
Then you've got what we call feedback modules.
Okay, so this is where the quality control comes in.
Exactly. These modules are all about making sure the AI isn't just spitting out random nonsense.
What do they look for?
They focus on three key things: novelty, validity, and clarity.
Makes sense. Break those down for me.
So the novelty checker makes sure the hypothesis is actually new. We don't want our AI plagiarizing.
Yeah, that would defeat the whole purpose.
Then there's the validity checker, which makes sure the hypothesis is scientifically sound.
Oh, it's got to be a tough one to judge, right? Because wouldn't you need to actually do experiments to really prove a hypothesis is valid?
You're absolutely right, and that's a challenge for sure. For now, these modules rely on LLMs and other models to assess whether the hypothesis at least makes sense in theory.
So like a pre-screening to weed out the obviously flawed ideas before they reach a lab,
Exactly, and then finally you got the clarity checker.
which makes sure the hypothesis is well explained.
And detail, yeah, like a good scientific writing coach.
Okay, so we've got the AI finding inspiration, getting feedback. What's the next stage in this main trajectory?
It's the evolutionary algorithm.
Sounds intense.
Well, just like in nature, these algorithms help the LLMs refine their hypotheses over time.
Survival of the fittest for scientific ideas.
Exactly. The best ideas survive and get further developed, leading to increasingly sophisticated hypotheses.
So it's constantly experimenting, learning, just like a real scientist.
Precisely. But sometimes one single inspiration isn't enough.
So what happens then?
That's where leveraging multiple inspirations comes in. Think of it like solving a complex puzzle. You need pieces from different sources to get the complete picture.
Can you give me an example of how that works in practice?
Sure, let's look at MooseChem again. Imagine a really complex scientific question. MooseChem breaks it down into smaller steps and draws inspiration from different sources for each step.
So it's combining different ideas, like a master chef combining different ingredients.
I like that analogy. It's a good one.
So we've got the AI finding inspiration, getting feedback, even evolving its ideas. What's next in this scientific AI journey?
Well, once you've got a bunch of hypotheses, you got to figure out which ones are actually worth testing.
Right. You can't chase every rabbit hole.
Exactly. That's where ranking of hypotheses comes in.
So you're saying there's an AI that can tell us which ideas are most likely to lead to breakthroughs.
That's the goal. Some systems use automatic evaluation methods to rank hypotheses based on their potential.
So it's like a triage system for scientific ideas, helping researchers prioritize their efforts.
Precisely, and this is where things get even more futuristic.
Really?
We're talking automatic research question construction, LLMs, taking the reins and identifying potential research questions on their own.
Wait, hold on. So the AI is coming up with the research questions themselves.
Exactly. It's like a self-driving car for science.
Now that's both exciting and a little unnerving.
Yeah, it's a lot to process.
So we've been talking about how these systems use existing research to come up with new ideas. But what about all the experimental data that's already out there? Can LLMs use that to make discoveries too?
Absolutely. That's the whole world of data-driven discovery. It's about unlocking hidden knowledge from the mountains of data that scientists have already collected.
That sounds like a gold mine of potential insights just waiting to be unearthed.
It is, and we'll dive into that right after this.
All right, so we were just talking about data-driven discovery, and I gotta say, I'm really curious about how LLMs can actually use like raw data to generate new scientific insights.
It's a whole different ballgame compared to working with published research.
Right, because it's not about connecting the dots between existing ideas. It's about finding patterns that no one has even noticed before.
Exactly, and it's an incredibly exciting area. You know how scientists have been collecting data for centuries?
Yeah, mountains of it.
Well, it turns out a lot of that data is just sitting there untapped like a treasure trove of potential discoveries.
It's like having a giant library of scientific clues, but no one to decipher them.
Exactly, and that's where LLMs come in. With their ability to find patterns in massive data sets, they're perfect for this.
So they can sift through all this data and identify hidden connections.
Right, and then generate hypotheses that might have been completely missed by human researchers.
That's incredible. It's like having an AI detective piecing together the clues to solve a scientific mystery.
I like that analogy, and there are already some really interesting examples of this in action.
Oh, really? Like what?
Well, one of the leading benchmarks in this area is called Discovery Bench.
Discovery Bench, okay.
It's a collection of tasks, each with a specific research question and a set of experimental data.
So like a set of scientific puzzles for the AI to solve.
Exactly. The goal is for the LLM to analyze that data and come up with a hypothesis that can explain it.
And I'm guessing it's not just about finding any solution.
Yeah.
The hypothesis needs to be good too, right?
Of course, it has to meet those same criteria we talked about before, novel valid and clearly explained. It's a real test of the AI's scientific chops.
So we've seen how LLMs can generate hypotheses by connecting existing knowledge and by finding hidden patterns in data. But can they actually do science? Can they, like, plan and execute experiments in the real world?
That's the question everyone is asking, and the answer is becoming increasingly clear. Yes, they can.
Wait, really?
In fact, LLMs are already being used to automate various parts of the experimental process, from optimizing experimental designs to actually carrying out experiments in robotic
Hold
labs.
on, robotic labs. Are we talking like those sci-fi movies where robots are mixing chemicals and running tests?
Uh-huh. It's not quite that cinematic yet, but we're getting there. There's a
Yeah.
system called ChemCrow, for example.
Chemcrow, okay.
It's an LLM that can plan and execute complex chemical syntheses using a set of expert designed tools.
So the AI is not just coming up with the recipe, it's actually cooking the meal.
That's a great way to put it. And it's not just chemistry. There are systems like CRISPR-GPT, which is designed for gene editing experiments, and ChatDrug, which can plan and execute drug discovery workflows.
It's mind-blowing to think that these complex tasks, which used to require years of specialized training, are now being automated by AI.
It is, and it has huge implications for the pace and scale of scientific research.
But you're not saying that these systems are going to replace human scientists altogether, right?
Not at all. It's more about augmenting their abilities, giving them superpowered tools to accelerate their research.
So it's like giving scientists a team of AI assistants to help them do the heavy lifting.
Exactly. Think of it this way. The AI can handle the tedious and repetitive tasks, freeing up human scientists to focus on the big picture questions, the creative leaps, the things that require uniquely human intuition and insight.
That makes a lot of sense.
Yeah.
So it's all about collaboration, humans and AI working together to push the boundaries of science.
Precisely, and that's where I think the real excitement lies.
But once the experiments are done, someone has to write up the results, right?
Ah, yes, the dreaded scientific paper.
Don't remind me. But wait, are you telling me that these AI systems can even write research papers?
Well, they're not quite ready to replace human authors just yet, but they're already proving to be invaluable tools for automating various aspects of the writing process.
Okay, I'm all ears.
Yeah.
How are they changing the game for scientific writing?
One area where they're making a big impact is citation text generation. Imagine having an AI that can automatically summarize the key points of a cited paper within the context of your own paper.
So no more spending hours reading through dozens of papers just to write a single citation.
It's a huge time saver. LLMs can do that heavy lifting for you, ensuring that your citations are accurate and relevant.
That's incredible.
Yeah.
What else can these AI writing assistants do?
Well, they're also pretty good at related work generation. You know that literature review section that every paper needs? The
Yeah.
one that feels like drinking from a fire hose of information?
Oh, don't remind me. It's one of the most daunting parts of writing a paper.
Well, LLMs can help you tame that fire hose. They can analyze vast amounts of literature, identify the most relevant papers, and even summarize their key findings, making it much easier to write a comprehensive and well-organized literature review.
So it's like having an AI research assistant who's read every paper under the sun and can instantly tell you which ones are important for your work.
Exactly. And it gets even more impressive. LLMs are even being used to draft sections of papers or even entire papers from scratch.
Wow. So these LLMs are helping with citations, literature reviews, and even drafting entire papers. Is there anything they can't do?
Well, one area where they're still finding their footing is peer review. But even there, LLMs are starting to make a difference.
Peer review? You mean those often soul-crushing critiques that every scientist has to endure?
The very same. But imagine if AI could help make that process faster, more efficient, and maybe even a little less painful.
Okay, I'm intrigued. Tell me more about how LLMs are shaking up the world of peer review.
There are two main approaches being explored: automated review generation and LLM-assisted review workflows.
So on one hand, we have AI trying to write full-fledged peer reviews, and on the other hand, we have AI acting as a helper for human reviewers.
Exactly. Automated review generation is all about speed and efficiency. These systems can analyze a paper and generate a comprehensive review covering everything from the methodology to the conclusions.
So it's like having a robot reviewer that can churn out critiques in minutes.
You got it. And this could be a game changer for journals and conferences that are overwhelmed with submissions. But of course, there are concerns about whether AI can truly grasp the nuances of scientific research and provide the same level of insight as a human reviewer.
Right, because science is about more than just ticking boxes and checking for errors. It's about understanding the big picture, the implications of the research, the potential impact on the field.
Precisely. And that's where LLM-assisted review workflows come in. These systems are designed to help human reviewers, not replace them.
So it's more like having an AI research assistant that can highlight potential issues, summarize key findings, and maybe even suggest improvements to the paper.
Exactly. And this kind of human AI collaboration could be the key to making peer review more efficient, more objective, and maybe even a little more enjoyable.
Okay, this is all incredibly fascinating. But how are these LLM-powered review systems actually evaluated? Do we have robot reviewers judging other robot reviewers?
That's a great question. Evaluating these systems is crucial, and thankfully, researchers have been developing specialized benchmarks to test their capabilities.
So what are these benchmarks like? Are they giving the AI pop quizzes on scientific knowledge?
Not quite, but they are testing the AI's ability to generate accurate, relevant, and insightful reviews. One example is MOPRD, a benchmark that focuses on editorial decision prediction, score prediction, and even scientific analysis.
Wait, scientimetric analysis? You mean like analyzing the impact and influence of scientific research?
Exactly. It's about evaluating the bigger picture aspects of a paper, which is something that AI is still learning to do effectively.
This is all so mind-boggling. It feels like we're on the verge of a scientific revolution, with AI playing a central role. But before we get too carried away with the possibilities, I think it's important to consider the challenges as well.
Yeah.
Every technological leap comes with its own set of hurdles.
You're absolutely right. LLMs for scientific research are no exception. There are some significant challenges that researchers are grappling with.
So what are some of the roadblocks in this field? What are the things that are keeping researchers up at night? So we were just talking about some of the challenges in this whole field of AI doing science. What are some of the things that researchers are bumping up against?
One of the big ones is what we call hallucination. LLMs, as smart as they are,
They're not perfect.
they can sometimes just make stuff up.
Make stuff up.
Yeah, generate outputs that sound plausible but are factually wrong or completely invented.
So it's like the AI is telling us a science fiction story instead of real science.
Kind of, and that's a little concerning if we're going to rely on these systems for actual research.
Definitely we need to be able to trust the results.
Absolutely. And researchers are working on ways to address this. One approach is to build in more robust fact-checking.
Okay, so like double-checking the AI's work.
Exactly. Imagine systems that automatically cross-reference the AI's output with giant databases of established knowledge.
So kind of like having a fact checker for the AI.
Right. Making sure it doesn't stray too far from reality.
Makes sense. Are there any other big hurdles in this field?
Well, another challenge is bias. You see, LLMs are trained on massive amounts of data.
Right, we talked about that.
And if that data has any built-in biases, the LLM will likely inherit them.
Oh, I see. So it's like garbage in, garbage out.
In a way, it's like teaching a student with biased textbooks. They're going to come out with a skewed understanding of the world.
So if an AI is trained on a data set of scientific papers that are mostly from one country or feature research by a specific demographic, it might overlook or undervalue other research traditions or perspectives.
Exactly, and that's something we need to be very careful about.
So how do we tackle this bias problem?
Well, we need to pay close attention to the data sets we're using to train these LLMs. We need to make sure they're diverse and represent a wide range of viewpoints and research approaches.
So it's about giving the AI a well-rounded education, exposing it to different schools of thought and making sure it doesn't inherit the blind spots of the past.
That's a great way to put it. We need to be very mindful about the data we feed these systems because it shapes how they see the world and the kind of science they do.
This has been such an incredible deep dive. It really feels like we're at a turning point in science with AI starting to play a much bigger role. What are your final thoughts on all of this?
For me, the biggest takeaway is that these LLMs are tools. Incredibly powerful tools, but still just tools. It's up to us, the human scientists, to decide how we use them.
So it's not about AI replacing humans.
No, not at all. It's about humans and AI working together, each bringing their unique strengths to the table.
And hopefully that collaboration will lead to some amazing breakthroughs.
I think so. It could lead to a brighter future for all of us, with AI helping us solve some of the biggest challenges facing humanity.
This deep dive into the world of LLMs for scientific research has been truly mind-blowing. We've seen how these systems are already changing the way science is done, from generating hypotheses to planning experiments to even writing papers. And this is just the beginning. It's clear that we're on the cusp of a new era of discovery, one where AI will play an increasingly important role. But as with any powerful technology, it's up to us to use it wisely. So to our listeners, I leave you with this. If AI can help us do science faster and more efficiently, what groundbreaking questions will we ask? What new frontiers of knowledge will we explore? The future of science is in our hands, and with the help of AI, it's looking brighter than ever.